Welcome to HSC Maths, and today we're going to be covering quadratic functions. And I'm Minji Kim, and I'll be your teacher for today. So, what exactly is a quadratic? Well, as you see on the screen, a quadratic is a polynomial that has a degree of 2 or have the highest exponent of 2 for a base of x. The quadratic looks like a U1 graph, and the U is called a parabola. And sometimes the U can be upside down, so it looks more like a mountain. That point right there at the origin is the vertex where the parabola meets, which is the minimum or maximum point of the parabola. In this case, it's the minimum. A parabola can also look like this. As I said, it kind of looks like a mountain, and in this case, the vertex would be right over here, and it would be the maximum of the parabola. Here are some quadratic equation forms. We have standard form, which is a and then times x squared plus bx plus c is y, and then we have vertex form, where a and then x plus h squared plus k, and then h and k, h comma k is the vertex, and then we also have intercept form, where y is a times x, and then negative x, and then x negative x, and then x1 is going to be one intercept point, and then x2 is going to be one another x intercept. So we can graph quadratics, and if the x squared is a negative, if the coefficient of x squared is negative, the parabola will look like this at the bottom here, and if the coefficient of x squared is positive, it will look like a U, like up here, where a is either negative or positive. So, what would a parabola for x squared is y look like? Would it be the top one or the bottom one? It would look like a U, and a parabola for negative x squared, and then plus 20x minus 3 equal y would look like, and then it would look like the mountain. Graphing parabolas in vertex form. The vertex in a parabola from the vertex form is h comma k, and so parabolas also have a line of symmetry or an axis of reflection or axis of symmetry at the x value of the vertex. So y equal h would be the line if you were to visualize it. So first you would determine if the parabola opens up or down. You would find the vertex, and then find the y-intercept by plugging in 0 at 0 for x, and then finding what comes out, and then find some other points in the parabola. Just find a couple to the left and to the right of the intercept of the vertex, and then you can sketch it out. And you find the other points on the parabola by just plugging numbers into x, and then you'll get coordinates. So pause the video and try graphing out y equals 2 times x plus 1 squared minus 4 on your own. And we're back. Okay, so step 1 is the parabola opens up because the coefficient is greater than 0. And then the vertex is at negative 1, negative 4, because x plus 1 is negative, x plus 1 is x minus 1. And then the y-intercept is at 0, 2, because you can get negative 2 if you plug in 0 for x. And then you'll find some other points for the parabola. I just plugged in a bunch of numbers. And then you can generally find the shape of the parabola. Graphing parabolas in standard form. find the line or axis of symmetry using x equals negative b over 2a. For those who already know the quadratic formula, this should look very familiar. And then step 2 is choose 2 points left of axis of symmetry and 2 points right of the axis of symmetry, and then plug it into the original equation. So choose if the axis of symmetry was at, say, 0, I would personally choose -1, -2, and +1 and +2 to plug into x, and then you just kind of sketch it out. So pause the video and try graphing out y equals x squared plus 2x plus 1 on your own. And we're back. So step 1 is the axis of symmetry is at -1 because -2 divided by 2 times 1 is -1. Pick 4 points and then plus the vertex, and then you just plot the points and then you can sketch it out. So graphing parabolas in intercept form. So you determine the x-intercepts by looking at what is at x, and then the first x right here and the second x right here. And then you find the axis of symmetry by finding the average by just doing x1 plus x2 divided by 2, and then you substitute the x parts of the equation like this part here, and then with the axis of symmetry to find the vertex, and then you sketch it out. So to pause the video and graph y equals 2 and then times x plus 2 times x minus 2, and these are the steps, and then we're in this case -2, 0 and 2, 0 are the x-intercepts because it's -2 and then -2, which is -2 here and then just +2. And then find the axis of symmetry, and in this case it's 0 because -2 plus 2 divided by 2 is 0. And then you find the vertex by plugging 0 into x and x, and you'll find that the vertex is at -4 right here, and then you sketch it out. So there are 3 main ways to solve a quadratic: factoring, completing the square, and using the quadratic equation. And all of these involve turning the quadratic into the standard form, which looks like this, and then plug in 0 instead of the y, in the place of y. And then here we go, solving quadratics with the quadratic equation. There are a couple situations to keep in mind when you are factoring in order to solve a quadratic equation. One of them is when you have, say, ax plus b squared is 0. Or y. Let's put y for now. Assume that a and b are constants. We will find that if we expand it into ax plus b times ax plus b is y, and then you expand it from there, you will find that you get a squared x squared plus abx plus abx plus b squared is y. Then you can simplify it further because we know that we are currently assuming that a and b are constants. Then we have a squared times x squared plus 2abx plus b squared is y. Remember this. This is very important.